The mean of a discrete random variable is the theoretical mean outcome for infinitely many trials. So the mean can also be thought of as the expected value of the random variable. So we have a formula for this. If it's the same thing as the mean, we use a capital E to represent expected value, and that's equal to the sum of all the x times the probability of x. That's how we found the mean, and we're saying this is just the same thing as expected value. So let's look at an example from the world of gaming. Okay. In the Pick 3 lottery game, you pay 50 cents to select a sequence of 3 digits. If your sequence is drawn, you win $250. Okay, so how many different selections are there? How many choices do you have if you're selecting any 3 digits for this Pick 3 lottery game? Well, your choices are, you could have as low as 0, 0, 0, right? That's the lowest possible number you could select if you're selecting a sequence of 3 digits, and then that leads to our highest value, 999. So how many different selections are there? Well, that would be 1,000 selections. If we counted all the possibilities, we would have 1,000. Okay. Well, what's the probability then of winning? If you have 1,000 possible choices, but only one of those is the winning 3-digit sequence, then of course your probability of winning is 1 out of 1,000, which written as a decimal, 1/1000th. Okay. Well, if you win, what's your net profit? I mean, it says you'll win $250, but is that your net profit? No, you've already spent 50 cents. So this is $250 minus the 50 cents you already spent, right? So your net profit is $249.50. Okay, so what we want to do here then is find the expected value for this Pick 3 lottery game. Now that we know what the possible outcomes are, and we know the probabilities of those outcomes, we can then multiply across on the table. So let me show you how we would set that up. Okay, so our possible outcomes x, in words, our outcomes are that we win or we lose, right? Those are the 2 possibilities. Well, x is the money. If we win, how much do we win? Well, we said you'd win $249.50, right? You don't win $250 because you've already spent 50 cents to try to win this. So you win $249.50. Well, what's the probability that you're going to win $249.50? Well, that's what we saw right up here. We said that there was a 1 in 1,000 chance, or a 0.001 probability that you're going to get that. Now, what if you lose? How much money do you end up with? Well, this is a negative number, right? Because if you lose, you're out 50 cents. Well, what's the probability of that? Well, these are the only 2 possibilities here, right? And we know that the sum of our probabilities must equal 1. So the probability that we lose would be 0.999, right? Because this sums to 1. And these are the only 2 outcomes when you play this Pick 3 lottery game. You either win or you lose. So the sum of the probabilities in the sample space must be 1. Okay, so now we know we want to calculate our expected value. Well, that's the same thing as calculating the mean of this probability distribution. We've created a probability distribution. So the mean of this probability distribution, we said a nice way to do that in table form is just multiply across the x times the p of x, and then we can sum at the bottom of the column. So 249.50 times 0.001 is 0.2495. And negative 0.5 times 0.999 is negative 0.4995. Now we sum. And when we add these together, we get negative 0.25. So what have we found? We found that this E, our expected value, is equal to the sum of each outcome times the probability of that outcome, which we found to be negative 0.25, or another way to say that is a loss of 25 cents, right? So the long-range theoretical expected value for playing the Pick 3 game is that you lose 25 cents. Okay, that's any gaming thing you participate in, whether it's roulette or Pick 3 or lottery games, they're all going to involve a loss because they've got to make money, right? So everybody can't have an expected gain. But it's just how much is that loss? So this loss is 25 cents. Okay, we'll compare that. We'll do one more of these and compare. Let's look at a different example. Okay. Whoop. There we go. Okay. So our next example is a Pick 4. This time we're going to pay $1, but we can win $500. So twice as much. Pay twice as much, win twice as much. Let's see what happens in this one. Okay, how many different selections are there? Let's consider that again. All right, well, if it's 4 digits, we could pick from 0, 0, 0, 0 to 9999, right? So we see that we have 10,000 selections. Okay, well, what's the probability of winning? Well, only one of these selections is going to be the winning one that's drawn, so you've got a chance in 1 out of 10,000 to win, or written as a decimal, 0.0001, right? Okay, well, if you win, what's your net profit? Well, you're going to win $500, but you've already spent $1 to get to play, so you'll win $499. Okay, well, let's find the expected value of the Pick 4 game. So we'll do the same thing. We'll create our probability distribution, where our outcomes are either that we win or we lose. And if we win $499. And if we lose, we're out, we lost $1. So we're down $1. Okay, the probability that we win, we said, was 0.0001. And then therefore the probability that we lose is the complement of that, 0.9999, because the sum of the probabilities in our sample space has to be equal to 1. And these are the only two possible outcomes when you play the Pick 4 game. Okay, so to find expected value, we want to sum the x times the p of x. Okay, multiplying 499 times 0.0001, we get 0.0499. And here, negative 1 times 0.999, negative 0.9999. And the sum of the x times the p of x is negative 0.95. So our expected value is equal to the sum of x times p of x. We made a column, we summed it up, we got this negative 0.95, or that represents a loss of 95 cents. So, if you had an opportunity to play either game, which one's the better bet? Well, the pick 3 has a larger expected value. Larger meaning that a loss of 25 cents is a better situation or a larger outcome than a loss of 95 cents. So you have the better long-term loss is playing the pick 3 game because you'd rather lose 25 cents than 95 cents.